53%, so we'll see.
Okay. This is number 16 on page 286, lesson 5.4. The directions change here a little bit from what you were doing. It says find the total area of the region between the curve and the x-axis. So we're going to try to do this without a calculator. So the first thing we're going to do is going to graph this expression. So we're going to make an x and a y t-chart here. And I think they give us a domain here for number 16. They say x is between -2 and 2. So we're going to plug in the numbers from -1 to 2 into my expression, into my equation, so we can come up with a graph. So if you plug -2 in for x, -2 squared would be 4. 3 times 4 is 12. Minus 3, this would be 9. How about if you plug -1 in here, what would you get? 0, right. How about if you plug 0 in here? -3, good. And then plug a 1 in, you get 0. You plug 2 in, you get 9. Now we're going to sketch the graph. Going from -2 to 2. Our y-axis has to go up to 9, it looks like. 5, 6, 7, 8, 9. Graph all these points, so -2, 9 would be up here. -1, 0 here. 0, -3 would be down here. 1, 0 here, and 2, 9 up here. What shape is this graph going to be? It's a parabola, yeah. If you look at it's the highest exponent's x squared, so you should know that's going to be a parabola that opens up. The -3 has shifted it down 3 units, so it goes through the point 0, -3. The area we're going to try to find will be the area between the curve and the x-axis, so that would be this area between -2 and -1. This area between 1 and 2. If I find the integral between 1 and 2, am I going to get a positive or a negative answer? Positive, because it's above the x-axis. How about if I find the integral between -1 and 1? What type of answer am I going to get? Negative, because the area is below the x-axis. So even though we know area has to be positive, if we do the integral, we're going to get a negative. Now, this graph happens to be an even function. An even function, notice that the exponent's even. Even function is symmetric with the y-axis. That tells me that this area between 1 and 2 is the same as this area between -2 and -1. So let's just find one of these two areas, and then we'll just double it, because we'll know that they're the same, because of the symmetry. So do you think it'd be easier to find the integral from -2 to -1, or from 1 to 2?
1 to 2.
Yeah, why not use positive numbers if we can? So let's do the integral from 1 to 2 of 3x squared minus 3. Don't forget the dx right there. So let's take the antiderivative of 3x squared. So if I make that exponent 1 bigger, I get x cubed. 3 divided by 3 would be 1. Minus, what's the antiderivative of 3? 3x, good. Then I put my square bracket, going from 2 to 1. I plug in 2. 2 to the third power is 8. 3 times 2 is 6. Minus, then you plug in 1. 1 cubed is 1. Minus 3 times 1 would be -3. So I have -2 minus -2. Oh, something's wrong.
2
Minus, excuse me, 2 minus -2. So what's 2 minus -2? 4. So I know that this area right in here that I'm putting in purple is 4. So it also tells me the area, because of the symmetry, the area over on the left between -2 and -1 would also be 4. If you wanted to do the integral from -2 to -1 to check, you could, but why do extra work, right? Okay, where do you think we want to find the integral next? You could go from -1 to 1 and get this whole thing at once, or the other option would be to just go from 0 to 1 and just get this piece here and then double it. So you could do it either way. I'm going to go from 0 to 1, that way I don't have to deal with any negative numbers. But if you wanted to, don't bother negative, if it doesn't bother you to use negatives, then you could go from -1 to 1 and get it all at the same time. Let's do the integral from 0 to 1 of 3x cubed minus 3 dx. And we already know the antiderivative is x cubed minus 3x from 1 to 0. Plug a 1 into here, you get 1 cubed minus 3 times 1, so that's going to be 1 minus 3. Minus, you plug a 0 in here, you're going to get 0 minus 0. So that's going to come out to negative 2 minus 0, so negative 2. Why did I get a negative answer? Below the x-axis. So the integral from 1 to 0 equals negative 2. But I'm looking for the total area. When they ask for area, they want a positive answer. So the area is actually what? 2. So that's 2. The area from negative 1 to 0 would also be 2 then because of the symmetry. So what's going to be the total area between the expression, or between the equation and the x-axis? Well, right. 4 plus 2 plus 2 plus 4. So the total answer here, the total area, is going to be 12 square units. Any questions about that one?
No.